Hello students! Today we will be talking about Stanovich book Chapter 1. So this kind of goes over some of the problems in psychology with its perception among the public and a little bit about the science of psychology. So we'll dive into a lot of the topics that are touched on today in more depth throughout this whole course. In some ways this is kind of an introduction chapter to a lot of the problems we kind of come back to throughout the course. So take some good notes. And a lot of this material will come up multiple times, so if you don't understand a full in-depth amount from this, feel free to email me about it. But also we will probably be diving into each of these topics in more depth as we continue along in the course. So let's get started with this. First, what is the popular image of psychologists and psychology in society? Is it a good one? Is it a bad one? Why or why not? So think about it to yourself for a minute. Think about what you've seen of psychology in popular media, whether it be shows, movies, books, things like that, news articles. How are psychology and psychologists perceived by people? So another thing to do is maybe take a moment to just pause this video after I give this instruction, write down some of the most significant ideas in psychology that you are aware of from the past 25 years. So think back to your other psychology classes, whether it's in high school or like general psych. Think back to those classes, things that you found interesting, exciting, important, maybe something that you've heard on a podcast or something like that. What are some interesting ideas coming from psychology research that you think are the most important that have happened in about the last 25 years? So take a minute, pause this video, do that. Alright, hopefully you have something down, but if you don't, that goes to the next slide and what we're going to be discussing here. Some of you might not have much written down for that. You might not have one or two or three or four, probably few of you have as many as, say, 5 or 7 ideas from psychology that have happened in recent time. So in 25 years, that's fairly long. So that goes to show that a lot of people, the general perception of psychology may not be what current psychology is doing. A lot of psychology and the perception of psychology comes from the history of psychology. And a lot of that comes down to general courses kind of going through a lot of the history of psychology. So that's one of the things people remember from going through, say, a general psych class is some of the history. But general classes don't do a great job about teaching you what today is going on in psychology. What are the problems we're working on? It's higher level classes that do that. And so the people maybe making media, say, or writing newspaper articles, making TV shows, might not actually know what current day psychologists are really doing. So who do most people think of when they think of psychologists? So probably for most Americans, it is Sigmund Freud, Dr. Phil. These are probably some of the people that come to the forefront of your mind when you're thinking about who are psychologists. The thing is, these individuals don't really represent psychology and the science of psychology in the same way Einstein represents physics. So when you look at Einstein or a picture of Einstein, you're like, oh yes, Einstein did science, had theories, things were tested, was seen as really important in the field by his peers. You can't really say the same things about these others. Obviously, Sigmund Freud was one of the initial psychologists and did a lot of work to start clinical research and things like that, but himself was not necessarily a scientist, and that's kind of one of the topics we'll talk about a few times. Dr. Phil, I don't even remember what Dr. Phil's degree is in, but not exactly a representation of the modern psychological science. So, what is it that psychologists actually do? If those aren't the best representation, and I'm saying a lot of media might not know what's going on the most recent 25 years or even 10 years in psychology, what do we actually do as psychologists? Or what might you do? So people generally believe that psychologists are clinicians who work for themselves or in clinics doing applied work, therapy, that kind of thing. So, but most of us aren't. Most psychologists are not doing that. If you look here, you can see the employment settings for PhDs. So a lot of them are in for-profit and self-employed, maybe federal government, state and local government, nonprofit organizations, college or university level, other educational systems. So there's a lot working in education, for profit and self-employed. That's kind of that could be applied work in clinical type of settings, but a lot of that is also, as well as the nonprofit, a lot of that is not clinical settings as well. So this kind of shows this a different way. So a couple different ways to chart these numbers, and it can show the change. This one also shows the change in years. So there's a lot of different things that psychologists do beyond just clinicians. So there's a whole wide variety of people who are not clinicians but are psychologists. So Lilienfeld summed up the image of psychology and psychologists this way. And for these couple slides, I will read them. They're not too long, but if you want to, just pause and read it yourself and skip over me reading them. Totally fine with me. So, although most laypersons view psychology at least somewhat positively, sizable minorities do not, and many doubt its scientific status. And that's a big part of Lilienfeld's papers and books and things that we'll be talking about from Lilienfeld, is that people don't understand that psychology is a science. So many people continue to have poor understanding of psychology's scientific worth, especially its contributions to society and applicability to a broad array of everyday problems. So some of my peers, for example, some of them are working in kind of more traditionally clinical type of settings, working with parents or families to help them thrive. Other people that I've worked with are working in nonprofit organizations that try to do evaluations for companies and other nonprofits that are trying to do things like work to solve homelessness or work to get more resources and more food to certain people in different populations. So there's a lot of things that psychology can do to be applicable to everyday problems. Some of the things I'm doing are helping with, say, character education programs. So helping young people to learn and build those kind of character skills and strengths to help them do well in their lives and thrive, and as well as in their jobs. For me, that motivation is kind of secondary, even though it's often like sold as like, hey, these skills will help you do better in the workforce, and they will, but they'll also help you do better in life. That's what I'm more interested in myself. But it's often how we have to sell these programs to, say, schools or people is, hey, this will help you do better, not just in life, but in work. So, with that being said, psychology is defined. So this is literally the definition, well, one of the ways to define psychology. But they all kind of cover this. If you look in your general psych book, the first chapter of, say, a abnormal psych textbook, first chapter of a developmental psych textbook, it'll have a definition of psychology that's really similar to this. Psychology is the scientific study of the mind, behavior, and mental processes. So mind, behavior, mental processes. How do we make memories? That's a mental process. So, and the scientific study of that. Behavior. Why do some people help and other people not help? That's a behavior. Why do people act certain ways in groups and not when they're not in groups? Behaviors. So the mind. How do we think about things? How do we process through, say, moral dilemmas? How do we make a decision about which politician we might vote for? Those kinds of things. So the mind, behavior, mental processes. I'm trying to make examples that are also relevant to applicable things. So memory, for example, you need memory to do well on tests and to remember your shopping list. So what is science? So this is a really brief thing. Again, these are things that we're going to be diving into in a lot of depth throughout the course. So what is science in brief? Systematic method. So you might have heard it called the scientific method. So it is a systematic, a method, a system of doing things to observe, describe, predict, and explain the mind, behavior, mental processes. So we use things like experiments. You've probably heard of experiments before. You might have, say, a control group and a treatment group. You do one thing to the treatment group but not to the control group, and you compare the outcomes. That's an experiment. Quasi-experiments, very similar. We'll talk about them in more detail, but you generally don't have as much control over the variables as you do in a true experiment. Correlational studies. So how is X related to Y? How is depression related to creativity? How is gratitude related to well-being? So how are these related to one another? That's correlational studies. So you might do, say, surveys. You can even do, say, other ways to get quantitative data to look at relationships between these kind of variables. So a variable is basically, again, we'll talk about these things in much more detail. A variable is something that varies. So your level of gratitude can vary. If you're given a little gift, but it's really meaningful to you, your level of gratitude might be really high. If you're given a little gift that's not as meaningful, your gratitude might be a little lower, for example. So that is how we would measure correlations, comparing that level of gratitude to your level of well-being. So, what are some example studies you know of, in psychology specifically? So take a minute, stop and think, write down any studies that you're aware of within psychology, things that you've heard from other classes, not just basic facts that you know about psychology, but the actual studies that got you to know those facts. So take a second to think of those. All right, so hopefully you did pause and write those down. So some that you might have listed down are things that are often in, say, a general psych course. So Milgram study, the Ash conformity study, the Stanford prison study. Also, you might have heard of, say, the marshmallow experiment. So hopefully there are some that you're aware of. So hopefully others that than just what I described there too. So those will be good to pull on to say, hey, how scientific was this? How does this match up with the things that we're learning in this class? But in this class, we'll talk about a lot of other studies as well that we've used to learn about the mind, behavior, mental processes. What are the systematic methods that we use to figure out those things? All right, so with this, psychologists who work in clinics or hospitals see themselves as scientist practitioners. So they're doing science as well as practicing science. So psychotherapists and psychological scientists have a really similar relationship to one another as medical doctors have to biological scientists. So the medical doctor might not be training in obviously they're going to take biology courses and anatomy courses, but a biological scientist is going to focus a lot more on the actual biology and how things work together than the doctor by themselves. The doctor is going to spend more time learning about how to do certain treatments, how to do certain surgeries, but they work together. The knowledge that the biological scientist gains can be given to the medical doctor. Things that the medical doctors realize, hey, this is a problem, what do you have to say about it? The biological scientists can study it. So it's a back and forth between them. So psychotherapists, so the people doing maybe the applied work, and psychological scientists are also working together in the same way. Obviously, you can have a doctor who is also a biologist who is doing those studies. You can have a psychotherapist who is doing their own studies as well. But oftentimes it's kind of two different groups that are communicating together and working together to make things better. So here's your mental health professional. They should be a consumer of science. So this therapist should be consuming science, reading what is the most up-to-date research on treatment of anxiety. So evaluator of science, they should have a good literacy of science and understand how science is talked about and discussed and what science is to be able to say, oh, this was a better study than this one, or this one shows me a lot better results than this one. So this treatment better than this one. They should evaluate. And they can also conduct their own research. They might not, again, every therapist might not necessarily use their own research, but oftentimes within their clients' lives and trying different treatments for them, they will use a scientific approach to see what works best. So, I recently was in a really severe accident. I have a surgeon and physical therapists as well. So my surgeon and physical therapists, they're scientist practitioners as well. The one thing, I went to a couple potential surgeons before my actual surgery, and the one thing I really liked about the one that I ended up with in the end and had doing my surgery on my knee was that every time I was talking to them and asking them questions, rather than just telling me the answers, they were talking about recent research in the field that shows, yeah, more recent research or new meta-analysis or this new paper with a big sample size really shows that for athletes this tended to be the best, and since you're a little more active that's probably more relevant versus another study showed that doing this might be really helpful for people who are older. So these are your options. This is what the research says. Let's make a decision based on that. I would encourage you to do this based off of your body type and what the research shows for people who have, say, a little more athleticism than someone who's in their 90s. So that was the kind of discussions that we were having with my surgeon. And so they clearly knew they were a consumer of science. They evaluated that science and they were able to apply it in their work. This is what therapists are doing or should be doing as well. My physical therapist as well. I come in and I ask questions about next steps to be taken or how long we should expect me to stay within like this phase of doing this work, and they will always be saying, oh well, the most recent research says that on average people take in between, let's say, 3 months and 6 months to recover from this or to get to this next step. And so talking about and even pointing me to the authors of different papers. Now that's not necessarily necessary. They know that I do research, and so I'm really grateful that they tell me the authors, because I actually went and looked up the papers on Google Scholar and through other library resources so that I could see, oh yeah, they're actually right. These are the most up-to-date work in the area. And it really helps me to know that, hey, they are good, what was the term we just used? It's just scientist practitioners. They are good scientist practitioners. They are practicing based off of the science that they are consuming. And that's what we want psychotherapists to be doing as well. Again, this class is not only focused on psychotherapists, it's mostly focused on that science piece of it, but that's what I want therapists to be doing. If I'm looking for a therapist, they should be someone who knows more recent research, who knows the current treatments, who knows alternative kinds of ideas around in the field that are better or worse, and be able to talk about those things as well if I ask them questions about them. I'm not quizzing or grilling them just in talking about a treatment plan. They should be pulling out things from what they knew from their consumption of science. So that is one reason why consuming science and becoming literate within science is such a big deal in this class. So I myself am also a scientist practitioner. So some of the applied programming that I've created, this was one of the first things I created with a team, was a guided breathing meditation. There's a lot of research that says long programs, like week-long programs of mindfulness meditation, can decrease stress, anxiety, improve other health and well-being factors. And so our question was, well, does something shorter help? Can we do something really short and free? Because those programs are long, they're expensive, but what about someone just starting in? Will they get an immediate benefit? How long does it last? And what we found was that this essentially 7.5-minute video, we did an experiment. We gave people a 7.5-minute video of guided meditation with a nice waterfall sound kind of in the background where they're kind of guided through meditation. It was intended for someone who's never done mindfulness meditation before. And we had a control group that watched the same length video of a brewery tour. So not something that should make you more mindful or less stressed, kind of just a neutral, kind of an interesting video touring through a brewery. But same length, same voice tone and sound from the person guiding you through either the tour or the meditation. And so we found with that the treatment group, the group who had the mindfulness meditation, they did indicate less stress from their pre-test to their post-test. So we did a true experiment there. I did experiments with these fostering purpose activities. We had, I think at one point, I think the most we created was, say, 21 different activities. And we essentially did experiments to narrow it down to what actually works, what helps people increase in purpose. So I used the science that we already had. I consumed science, and knowing what we knew, we said, okay, so these things should probably work to increase purpose. So we did some applied work, we created activities, and then we sent them out, did experiments, and saw, oh, A, B, and C don't work, but D, E, and F, they really work. So we threw away the ones that didn't work or modified them and tried to make them work again. In some cases that worked, in some cases it didn't. But I'm also a scientist practitioner, so doing things to help people increase pro-social behavior is another thing that I do. You might call it character education. That goes back to my research in heroism as well. So I myself do the research and do the applied work too. So I'm not in a clinical setting one-on-one with clients, but this is where I bring in the science and practice with it. So with this, This might be part of your discussion board. I'm recording this before I finalize which discussion boards are for which weeks. So this might be part of your discussion board. It might not. The main point about looking at your lists of what is important, what's relevant in society about psychology, is that there's kind of a lack of agreement about what are the biggest changes. But that's okay. This lack of agreement about what are the biggest, most important changes of psychology show that it's a rigorous and healthy science. It's very broad. So the science itself does anything from how does memory work to, hey, how do we help people increase their purpose? So that's kind of a broad range. How do we treat anxiety, as well as how do we help people increase things like prosocial behavior? So there's many areas of psychology that are changing very quickly, and there's some that are a little slower as well. In my personal opinion, I think this disagreement about what's the most important in psychology in general also shows that the umbrella of psychology is really large. So there's that wide range. We've got neuroscience that's looking at how our memory is actually stored at the neural level. There's a lot of similarities, but some differences going around to how do we increase purpose in people's lives. So it's kind of a large umbrella. Sometimes I think maybe it's too large. Maybe at this point we need to start breaking up psychology and have maybe a general social psychology class rather than a general psychology class, or an abnormal psychology general class. So have these different fields of psychology have a little bit more focus from the beginning. But I do see the relevance of trying to pack it all in into a general psych course when it might be everybody's first taste of what psychology actually does. So, as an example, physics, chemistry, geology, you also have things like astrophysics. That's physics focused on space. You also have exoplanet geology, focused on geology in space, and exoplanet chemistry, focused on chemistry in space. So these are all maybe subgroups under that bigger umbrella of chemistry, geology, or physics. And so I feel like maybe psychology needs to do a little bit better job of narrowing into those areas. As you go further in education, you do go that way. You narrow down, say, a path to developmental science and developmental psychology in my case, or social psychology or abnormal psychology. Maybe that needs to happen a little earlier, but we also need to have people have a better idea, maybe coming out of high school as well, what is psychology in general. So, how many disciplines are in psychology? What are the diversity of topics that we study? So one way that we can look at this is that a lot of these areas of studies have divisions of the APA, the American Psychology Association, that look into them. So, can you guess how many divisions of the APA there are? Just write down a guess really quick on a scrap of paper or even a Word document that's open. It's 54. 54 different divisions of the American Psychology Association that are essentially different divisions or subjects within psychology. Here they are. So you can probably see some overlap in some of these. So just pointing out a few: developmental psychology and family psychology, those are pretty overlapping, right? But developmental psychology and adult development and aging, those are also pretty overlapping. Applied experimental and engineering specifically, that's very industrial organizational focused. I wonder if there is a specific industrial organizational division. I'd be surprised if there was not. I can't find it. It's probably here, but also looking through so quickly. So we've got psychotherapy, we've got psychopharmacology, so this is more medicine, this is more therapy for disorders. Experimental psychology kind of touches on a lot of these. So there is overlap between these. If you meet someone who is a psychologist and doing research, they probably would fit into multiple of these. So humanistic psychology, I feel like I would fit into. Developmental psychology, I would fit into. Family psychology, I would fit into. There's a couple more. I'm not going to spell out the list of whatever 10 or 12 that I fit in here. But this gives you an idea of all the different ranges of psychology. So exercise and sports psychology, specifically, that would be really relevant to my physical therapists. They've actually talked about exercise and sports psychology research with me. But that's a little bit different than, say, psychotherapy, right? Some of the ideas and research might transfer over and be relevant, but not all of it, right? So in this, we're looking specifically at exercise and sport. If you're talking about recovery, we're talking about getting past anxiety, there might be some really relevant things from this area of psychology that's going to be relevant here. So we're all kind of working together, but we all have our kind of areas that we're focused on as well. So with that being said, how many peer-reviewed journals do you think the APA publishes? So a peer-reviewed journal is that kind of journal that I as a researcher might submit an article to. They would send it out to peer reviewers. The peer reviewers would check that things were accurate, things were clear, maybe even sometimes check the data analysis as well, make sure that it's in line with the previous work, make sure I didn't make any major mistakes, and then it might get published. So the APA is one publisher. Guess how many journals they publish? Usually journals are focused on one of these topics. I've had 54 divisions of the APA. How many peer-reviewed journals are there? 90. There are 90 different journals that just the APA publishes. So there's a lot of other journals that the APA doesn't publish as well that are peer-reviewed also. So there are a lot of journals in psychology focusing on other specific things. So this course as a whole is really designed to help you better understand the science of psychology and see a little bit more of this broad view of all of the different areas and how we all use science. So there are some really critical topics that you need to have a basic understanding of before you go further in any of these fields of psychology. These are things like statistics, research study and methods design, ethics, reading and writing, and understanding research. So a lot of this class is focused on these 4 things. If you have done or are going to do a statistics class, you already know more than we're going to cover in this class, so don't be too afraid of how much in depth. We're going to go over like the concepts behind statistics, but not actually like calculating statistics and doing the math. Usually we do that with a computer anyway. So as long as you understand the concepts and how it's relevant to, say, study and methods design. How do you compare which group, the control group or the treatment group, how do you compare which one actually did better? What numbers do you use to see and prove or see which one is better or worse? So let's watch a little bit more about the scientific method in some more depth here, and I will interrupt this at different points to talk about some of the specifics relevant to psychology itself. Hopefully the audio will pick up my speaker. I'm going to put my microphone right next to it, so hopefully that works well. If not, this is the I'm going to watch this back before posting it, and I might just re-record this portion of it if it doesn't work. So hopefully it will work first time.
Science isn't like... Science is more of a process of learning about the universe and organizing that information so that we can build on it. And just like most processes, there's an accepted way of doing scientific investigations on everything from the movement of atoms to the mating habits of tree frogs. This technique is called the scientific method, and it's got its rules just like golf and the US postal system. As much as we take the scientific method for granted, the fact is that it took thousands of years for us to figure out how to actually practice the discipline of science, and it served us pretty well. A lot of what we know about the world has been discovered and tested and verified through the use of the scientific method, or at least versions of the one that we use today. But of course, not all scientific knowledge has come to us through this method. Many revelations came about because of flashes of inspiration or just plain luck, rather than by testing theories in labs. What's more, some experts say that the scientific method can only take us so far, that we as a species have reached a level of understanding that requires new methods to help us get to the finer truths of how the universe works. So I have news for you. The scientific method is not perfect, but it's the best thing we have for now.
So a lot of this video will be focused on that point, basically the history of the scientific method, and I'll come in and talk about how it's relevant to psychology, but it's also going to talk about what does he mean by flashes of inspiration or creativity, how is that relevant to the scientific method, and how is that used for how we do science. Also, I sped it up a little bit. It's at 1.25. So if that's too fast for you, this is recorded on YouTube. You can slow this whole video down with the settings down here, or you can watch it on your own and slow this video down as much as you want if this is a little too fast for you.
The scientific method is all about coming up with a plausible explanation for an observed phenomenon, and then shooting that possible explanation with a machine gun full of facts and questions until you either A, destroy that seemingly plausible explanation, or B, decide that it's indestructible. So science is working tirelessly night and day to disprove its own theories about how the world works, or at least that's what science thinks it's doing.
So with that, we'll talk about the definition of theory in another class. But with that, science is trying to do that. It has a theory which you don't have to necessarily write this down now, but is a big, broad set of ideas and explanations and data to explain how things work. So what about the mind, behavior, mental processes, to explain how memories work, for example. So you might use theories to talk about those, and those theories are actually a bunch of data that's agreed upon and been seen through experimentation, correlational studies, to be pretty accurate descriptions of how does memory making work. So theory is a big, broad set of ideas. So with that, you're testing and trying to see how that could be explained. You're testing, does that theory hold up in, say, mice and humans? Knowing what we know about this theory, that means I should be able to help someone improve their memory by doing X, Y, and Z. Did that actually work? If we see that that doesn't actually work tons and tons of times, then we might say, maybe there's something wrong with this theory. Maybe we need to adjust it, or maybe we need to throw it away altogether and start with something new. But let's see some examples of scientific method through history.
Want to find out something about the natural world, for example, why your dog is always dragging his butt across the floor, a scientist will advise you to go through a series of steps to find the answer. Step 1, ask a question. Why is my dog always dragging his butt across the carpet? Step 2, do some research, checking out the pet health websites, asking other people why they think their dogs wipe their anuses on the carpet. Step 3, propose a possible...
So that is similar to what you're doing with your lit review. You are reading previous research, you are trying to learn about a certain topic to answer a question that you have. That's how a lot of psychology research, that's how a lot of science just starts. You look at what's been done and asked and answered before, what are the current theories explaining things, and then what does it not explain? What could it predict? And then testing those things.
But testable explanation, aka a hypothesis. In this case, maybe he has worms. Step 4, test this hypothesis with experiments until you've disproven it. Like put his poop under a microscope and see if there's worms under there, or give him some deworming medicine and see if he stops soiling all the floors in your house. That's called collecting data. If he doesn't stop after you've dewormed him, you can probably consider that hypothesis disproven. So then you come up with another hypothesis and collect some more data on that. Each time you prove an idea wrong, you come up with another hypothesis and test until... Step 5, your dog quits wiping its butt all over the carpet, and then you can analyze the data you collected to draw a conclusion. Like, he was just trying to express a blocked anal gland, or he's just a bit of a perv, or whatever your data suggests. And there you go, science accomplished. You can go ahead and make your conclusions known to the scientific community now because you just did the scientific method. All this sounds
All right, so let's take that again. You collect information, you do a lit review, you see what's been said about something before, then you do your own studies, see if these relationships hold up in maybe a specific population. Maybe one thing that we'll talk about a few times in this class is that a lot of historical psychology research was done with white men who were middle class. So that group probably does not represent the entire population of the world. So maybe you can see that the theory is describing this is how such and such works within this group. But you could say, but does that work with this other group that I'm interested in? Maybe you grew up in a different culture or environment and you say, well, does it still work the same here? I feel like maybe it doesn't. So you can test in that group and either confirm or disconfirm your hypothesis that the prevailing theory does or does not explain how it works in this group. If you see that from a lot of different groups or even just that specific group, you might have to say, okay, we need to come up with new explanations, new big broad explanations for this group. So a new theory for this specific group or for any other group that's not white middle class men.
pretty reasonable because that's what we're used to. But that doesn't mean that science was always done this way. Some people credit Aristotle with inventing the scientific method because he was the first to say, hey, Truths about natural phenomena can't be discovered just by thinking really hard on your couch. You have to go experiment, like go out there and make some observations. Aristotle basically came up with the prototype for the scientific method, but by present-day standards, he was sort of a terrible scientist. We know that because almost all of the stuff he wrote about was wrong, like that time he said that females were anatomically just deformed men. Yeah, but his idea that theories could only be proven through experimentation and observation, called empiricism, eventually took hold. The problem was that empiricism was really most useful when lots of people were gathering data and sharing that information. This meant that science could only grow as fast as information could spread, and back in the days before the Google machine or the Pony Express or whatever, information spread like snails on NyQuil. Slowly, is what I'm trying to say. Like, we think of the Middle Ages as being a time when everybody just sat around getting the plague and watching the Roman Empire collapse. But in fact, the Dark Ages of European science were actually the golden age of Arabic science. Muslim scholars preserved the knowledge that had made its way from ancient Greece and built upon it, while the Europeans were mostly on intellectual hiatus. In fact, if you want to call somebody the father of the scientific method, the best candidate would probably be 10th century Arab scientist Ibn al-Haytham. Ibn al-Haytham did amazing work on light and optics, a topic on which he wrote 7 books. He used math to prove that we see light that enters our eyes and not because light comes out of our eyes.
So this is a good example of a theory. So there were multiple books describing in multiple instances of math explaining that we see from light coming into our eyes. So the general theory of how do we see was before this, that light comes out of our eyes and it gets reflected. I don't actually know too much about that theory in general, but I know a lot more about how we actually perceive light. It comes into our eyes, it hits rods and cones. I don't know that this person had access to things like microscopes and understood cells at this point in history, but the basic theory, or an example of the theory, is that light either comes out of our eyes or goes into it. So you can do experiments. If light's coming out of our eyes, you could think of experiments that might either suggest that that's actually true or suggest that it's not. Enough experiments showing that, well, that's not actually how it works, would make you question, well, maybe this is not the best explanation. Maybe this is not the best theory. One single experiment will probably not do it, but multiple experiments might. And then multiple experiments with your new theory showing, hey, this is a better explanation. It explains everything the previous theory did and new stuff. That's going to give your new theory a lot more strength. And so that's one big way science is done. Any individual study might not shift the whole theory, but that one study is one piece of evidence to support or not support that theory. You get enough of those pieces of evidence, it makes things change over time. So the theories change over time, or abandon ones and create new ones. And that's why it's really helpful to have a lot of people working on these same kind of problems. Here we have some really impressive examples of individuals who gained enough knowledge to move things forward, but now we have lots of people working on them. It generally takes a lot of different studies, a lot of different people, hopefully in not too much time, to shift ideas and make theories even better.
Which was the prevailing theory of the day. He also developed a method for his inquiries that was based on first gathering data through observation and measurement, followed by formulating and testing hypotheses to explain what he observed. Basically, he invented a stripped-down version of what we roll with today. By the time Europeans were back in the game intellectually, a few key figures in Europe took the mantle of empiricism and fueled the scientific revolution, a period between the 16th and 18th centuries when finally the scientific method had been refined to a point where actual stuff could get figured out. This was science's first real heyday. Galileo studied astronomy and physics. Robert Boyle argued that it didn't matter how you felt about a theory or how beautiful it sounded, but only whether it could be backed up by experimentation. Francis Bacon argued that science was only science if it was trying to prove itself wrong. And Portuguese physician and philosopher Francisco Sanchez coined the term scientific method in 1581 to describe the process of gathering and judging data in an attempt to understand the world. But arguably, this centuries-long revolution peaked with Isaac Newton. His laws of motion and gravitation totally changed the game, obviously, but in his famous book Principia, he also laid out what basically became the official rules for scientific reason. Rules like all things that create the same effects can be assumed to have the same basic causes, and if you observe the same qualities in different bodies through experimentation, you can assume that all bodies everywhere have those same qualities. And last but not least, theories based on observation should be considered accurate until they are refuted by other observations. So the scientific revolution made the scientific method pretty much what we know today, and as a result, scientists gradually just started being scientists, not knights who happened to write books or monks who did genetics on the side. They also began following specialized disciplines like chemistry or biology. But here's the weird part: even though great science was being done using the scientific method, a lot lot of incredible discoveries were made without it. Take Marie Curie's insights into radioactivity, Albert Einstein's theories of special and general relativity, Nikola Tesla's AC induction motor, Alan Turing and the computer, and Richard Feynman's famous Feynman diagrams. All these scientists made discoveries either as a result of putting together pieces that had been discovered by others, or just because they saw the world a little differently than everybody else.
So this is one of the big keys with changing and paradigm shifts from one theory to another, is that often it comes from working with people who might see things a little bit differently. So I mentioned that I probably fit into multiple of those categories in the APA divisions. So other researchers that I work with fit into other categories. So working together with people who are more biology focused or neurologically focused or applied focused can really help. I even have a person I regularly work with that's a political scientist. So there's a lot of people working on similar things, and they bring different things to the table to help us further understand. Even though we've kind of trained in a specific discipline, working together collaboratively can really help make these movements, and coming up help us make new ideas that puts together information. And so that goes back to one of those first steps, putting together good scientific information. I can pull from my areas, they're pulling from their areas, and we come up with a new idea. So that's how a lot of changes are happening. It's not always just one individual making that jump. Oftentimes it's groups working together as well. But it's an easier story to tell when it's one individual like Einstein who really clearly did that.
In other words, those discoveries were made not through subjecting an idea to the method, but by creativity and a certain amount of serendipity, both concepts that would have made old-school empiricists kind of uncomfortable. By the 20th century, scientists were beginning to find that the scientific method wasn't really applicable to some of the problems that we were trying to solve. By that time, scientists weren't trying to figure out where babies came from like Aristotle was, or what made apples fall from trees. They were trying to refine our knowledge of the universe, and those finer details can get tricky to hypothesize about and experiment on. In 1962, American physicists.
So the next examples that they give are really good, but it can be hard to do actual true experiments on some of the things that we look at in psychology as well. So you cannot ethically subject people. You cannot, let's say, take twins without consent of, say, parents or things like that. You can't take twins, put them in different environments, and intentionally create environments around them to watch how they develop. I mean, like, you could do that, but it's not ethical, right? So with that being said, there's some things that you have to learn, not just by experimentation. Also, you can put together ideas in different ways that are novel, but you're still going to be testing them. You're still going to use these brand new flashes of ideas or new way to put things together and then test those things using empiricism. And this example, I think, will do a good job explaining that from, say, a physics perspective.
Physicist and philosopher of science Thomas Kuhn suggested that there wasn't necessarily anything wrong with the method, but that we were putting too much pressure on the method to do all of science's work. Kuhn suggested there were different phases of science. The first just being normal science, which followed the scientific method and tested hypotheses with experimentation, and everybody in a particular field had a shared understanding of their discipline. Within this framework, scientists got to the bottom of what was already known with more and more precision, and when something came up that seemed to go against how they understood the world, they either put it aside or treated the anomaly like a little knot, picking at it with the scientific method: observation, hypothesis, experiment. The only problem was that these unresolved anomalies tended to pile up and become so conspicuous that some scientists began to question what they thought they knew. Take gravity, for example. Newton figured out how it worked. The apple is being pulled toward the Earth while the Earth is being pulled toward the apple. Everybody used that framework for 200 years, until the anomalies started piling up. For instance, based on how other planets interacted with each other and how light bent in space, Newton's view didn't seem to be true anywhere except here on Earth. So Einstein came along and suggested the existence of photons, which pulled less massive objects toward more massive objects, and even pulled stuff with no mass toward a massive object. All ideas that Newton would have definitely objected to. And lo, classical mechanics made way for quantum mechanics, and physics has never been the same. So Einstein theorized creative possible solutions where the scientific method had left us high and dry. This is what Kuhn called a paradigm shift, or a complete change in the assumptions made about a certain area of science. During one of these shifts, scientists are willing to try anything, entertain any crazy notion, debate everything we took for granted to explain an anomaly. In the end, there's a change in how everybody sees the world, and the old way of thinking is replaced with a new one. Then, normal science takes over again. Observation, hypothesis, experiment. The scientific method's equilibrium is restored. Since Kuhn...
So one good example of this within developmental psychology, and hopefully you get this and can understand this from your developmental classes. I definitely make an emphasis of this in my developmental classes. But one really good example of this is the move from understanding about development as stages to development being much more continuous. There are definitely some things that happen in stage-like instances, that there's sudden jumps that you might call a stage, but we understand now that a lot more of development than we realized before is on big continuum, that there's little changes all the time happening with a lot of things within development, and that the end points, you could say, of development for anything is on a really big continuum. There's a lot more variety than we had previously thought in human experience and human life, and how humans are. So you can see that also in talking about things. So talking about things being on a spectrum, for example, it's the same idea that developmental psychology has shifted from these clear-cut stages over time to saying, well, actually, there's a lot more variety within these stages. There's a lot more things that affect the development of different things. So this has been a paradigm shift in the field of developmental psychology specifically. Takes a lot of social psychology into it, so those ideas kind of combine together. Humanistic psychology with that too. So a lot of those things change that paradigm from being really clear delineated stages to seeing evidence that, well, those stages don't actually explain things super well. We have a new theory of the relational developmental systems meta theory, or bioecological systems theory. So these are the current theories within developmental science that kind of explain how development works. And you could put it to put it really too simply, everything affects everything. There's a lot of variety in human experience. Most development happens continuously over time, even though there might be certain things that happen in stage-like ways. So, trying not to go too much on a tangent on developmental research and science, even though that's one of the areas I'm most knowledgeable in, it's a good example of a paradigm shift. And so these paradigm shifts happen when we ask questions, when we see that the prevailing theory is not completely working to answer everything that we're observing with our studies. So we make these observations and we say, hey, that theory didn't really explain this, or it didn't predict how this actually happened. Once those things start to pile up, we need to be a little more creative and say, well, what would explain these things? How can we explain this? Is there a better theory already? Did other people in the past or in a different culture already have an explanation that fits here? Do we need to come up with something brand new? And often it's kind of a mix of those things. Because as well as it talked about Arabic and and then Western-centric science, there's other science that was going on all over the world that we're seeing is very relevant to how we could explain things in slightly different ways as well.
No, more changes have been made to how we do science. I'm talking about computers here, lots of them. Because at this point, a robot can actually do science all by itself. In 2009, scientists in Wales built a robot that could successfully formulate a hypothesis, design and run its own experiments, analyze data, and decide which experiments to run next. Of course, the discoveries made by this computer were pretty modest revelations about the purpose of different yeast genes, but the point is, computers are the future of science. I mean, like, take CERN's Large Hadron Collider, that thing that's been turning out a gigabyte of data per second, enough to fill up a DVD every 5 seconds. That data is being sent to labs all over the world for analysis. There just aren't enough human scientists on the planet to process all that information. So if
Just as kind of a side note, I recently backed up all my data from all of the research projects I've done up to this point, and it was probably only like 25 gigabytes of data. So the fact that it creates that much data that quickly is just amazing. So I wish we had that kind of detailed measurement tools and techniques and software and hardware to be able to get that much data about how human minds, behavior, and what was the last one? Minds, behavior, and mental processes work. That would be really neat. We could learn a lot more.
computers were the ones actually following the scientific method, human scientists would be freed up to do the cool stuff, the collaboration, the creative thinking, the serendipitous observing, the strategizing about what steps to take next. At the very least, they'd be doing a lot less pipetting. And that would obviously change a lot about how we think about science.
So pipetting is literally when you have, say, a chemical or a solution or something in front of you. It's a little tube with a little dropper thing at the end. You literally pull on it to withdraw the chemical. You put it in something else. So you might use that in gene research. You might use that in basically any chemistry where you're trying to take a solution or some kind of thing from one solution to another solution. That's what pipetting is. You put it in a little pipe, and then you put it in another little pipe, and then you put it in an analysis tool. That's what pipetting is. It's relevant here. It'll come up later on in the course as well.
It would affect everything from the skill set we look for in a scientist to the way that science is taught in schools. It would basically change the definition of science, at least as far as humans are concerned. And as dependable and comforting as the scientific method is to have around, and as much as I love pipetting, that's kind of an exciting prospect. Thanks for watching this episode of SciShow. If you have any questions or comments or suggestions, you can find us on Facebook or Twitter, or of course down in the comments.
All right, so a lengthy video that hopefully now some of you might be even more confused about what is science. What do we do when we do science? And that's okay if you're a little confused, but hopefully for a lot of you, having taken other courses, talking about science in high school as well as general psych, hopefully a couple other psych classes before taking this one, hopefully you have a couple things to pull from and be like, oh yeah, that makes sense. This is how science is done. If not, totally okay. That is one of the purposes of this class, to essentially make this video make more sense and dive into each topic in a ton of detail. So, what is science? Again, in a little more depth than my brief description earlier. Systematic empiricism. You just heard that word, empiricism. That's essentially taking data, like getting systematic data to explain the theory, to see if the theory's predictions actually come out to be true, to see if another theory's predictions are better. So empiricism is finding evidence in the world. So science involves asking questions and empirically taking a look. So you might do that with pipetting, looking at the chemical composition, or how many cancer cells exist, how many virus cells exist. I don't think viruses are actually cells, but that's beside the point. By looking at that, that's one way to measure. In psychology, we will look and empirically take a look. You could watch and literally watch, say, a playground. If you are wondering about prosocial behavior of elementary school students at recess, you might watch a playground and see, well, when do they do prosocial things? Did those kids over there share? That's one time. Did those kids over there help someone who fell? That's two examples of prosocial behavior. So you could literally count those instances and write down. You could take a look, and that is a systematic way to watch prosocial behavior during recess for elementary school. So, all right, so I got ahead of myself in my explanations there. So empiricism is taking a look. So systematic empiricism is the better one. It means that there are better and worse ways to take a look at things. Not all evidence is created equal. So when you are trying to learn about young people's prosocial behavior in elementary school, you could take a lot of different methods. You could just ask the young person. Be like, hey, what kind of prosocial behaviors do you do? You could ask a fourth grader that, and they would maybe give you an answer. They might look at you very confused. Probably better to ask them in a more systematic way that can get you better answers and get at what you're trying to ask. So rather than saying something like prosocial behavior, something like sharing. Ask them specifically about sharing. So there are a better and worse way to interview someone. There's a better and worse way to take data on that playground. So I could sit at one corner of a playground. Obviously, I would have consent of parents, consent of the school, those kinds of things. I would keep the data safe for the kids. Let's assume I've done that stuff already. So I could just watch and try to tally things up. Or I could also have a video camera at a couple different angles, because I might not be able to see what's happening behind the slide. So which of those is a better way to take a look? I could also have a second observer or a third observer and see if both watching there as well as watching these videos, do we tally up the same number of prosocial behaviors? So which of those is a better way to take a look? Clearly the evidence where we have more reliability, where we have more people saying the same things, we have the additional evidence of the video cameras that we're looking with both our eyes and through the video, that's better evidence than just me on my own watching for specific behaviors. So evidence is stronger or better when it's collected in a systematic way, when it's something that's repeatable, when it's something that's reliable, when it's something that is valid. So if I made up some questions to ask someone about their prosocial behavior, I might get some information about prosocial behavior. I could literally create a survey. I could make it up right now, make it 8 questions about prosocial behavior. It might be pretty good. Or I could test that survey. I could see if it actually lines up when people actually do pro-social behavior. If it does predict pro-social behavior, it's probably a better measure than if I had just made it up. Or I could delete the couple questions that don't actually correlate or relate to people actually acting pro-socially. So something, a survey measure that's repeatable, that's reliable, that's valid. Valid means it's actually getting at what you want to get at. So if you want to get at sharing behavior, it's specifically getting at sharing and not gratitude. You would want your measure to be getting at the actual thing. Reliable means you're getting a consistent, repeatable result. So they score a 5 on sharing today. And you think sharing is a consistent characteristic. They get 5 today, they'll get 5 tomorrow, they'll get 5 the next day, they'll get 5 7 months from now. It's getting a repeatable result. So, and we'll talk about validity, reliability, scale creation, measurement in more detail. But the basic idea is there are good and bad ways to take a look at something. So we'll consider this in the rest of the class, essentially. So what is science as well? Publicly verifiable knowledge. So when I do my study about kids' pro-social behavior on the playground, I create that knowledge and I deliver it to other people publicly. And then generally scientists do this in 3 ways. We make it open to scrutiny. We say, hey, here at a research conference, this is what I found, these are the ways we did the data collection, or I send it to a journal, the peer reviewers look at it. And we can scrutinize our own, we can have other people scrutinize it and say, hey, you really forgot to look for this specific behavior. Your numbers might be higher or lower. Maybe you put this as pro-social, but it's really not very pro-social. So it's open to scrutiny. It's open to replication. So I find this in a group of, there's an elementary school nearby. So it's in the middle of the Salt Lake Valley. And so this population here might be different than the population of my kids' cousins in Georgia. So we can test both of these, see if it replicates, see if they have the same number of pro-social behaviors, maybe they have more, maybe they have less, and we can replicate that study. Someone else can come back to another school in the Salt Lake Valley and do that, replicate that same study and see, hey, do we get about the same results? So that's publicly verifiable. Did the original knowledge, does it hold up still? Is it replicable? And then peer review. So those peer reviewers often do this scrutinizing. They might look at your actual data, they might look at your interpretations and say, hey, your data says this, but you're going a little beyond what your data says in your interpretations. Something like that. So what else is science? Solvable problems. We're trying to look for applied and solvable problems. We look for questions that can't be answered by using when we're looking at questions, things that can't be answered using the scientific method are not seen as scientific. So answers that you can't collect data on, there's no way to collect data on, say, ghosts, for example. There's been attempts to answer questions about ghosts through the scientific method. We don't have any kind of measures that are relevant there, that we can't get systematically empirical data there. So not very it's an unscientific thing to look at. So we can really only deal with ideas that can be tested. That is experimenting, looking at correlational results that we can get some data on. So what is scientific changes as new technologies are available? So think about new technologies within the sphere of science that exists. We've talked about a couple today already. Large Hadron Collider, looking at the subatomic particles of smashing a couple protons together or a couple atoms together. We have that kind of technology now that they didn't have hundreds of years ago. We have better survey measures in psychology. We have measures that we can look at the hormone levels in a person's bloodstream or even in a person's brain. We have MRIs that we can look at the brain activity that we didn't have before, that we can look at which areas of the brain are actually active. We have better microscopes that can look at how neurons and other brain cells interact with each other. So these are new ways we can get data on things like how does the brain actually work that we might not have been able to measure scientifically in the past. So PET, fMRI, we have a lot better idea of how human consciousness works now because we can look at it scientifically. We can see which parts of the brain are active to make us as we are thinking, as we are processing things, these mental processes that are happening, we can look at that scientifically now. Versus before, couldn't do it. We didn't have the technology to do that. So that's why I say it'd be great if we had more kinds of tools like that so we can get so much more data, just like the Large Hadron Collider can pump out that much information so quickly. It'd be great if we had tools that we could pump out that much information to learn about the mind, behavior, and mental processes. So again, systematic empiricism is what science is. Publicly verifiable knowledge and solvable problems. So here we've got one example of a study. I'm pointing to the screen, but I have a mouse here. So here, this might be a test of reaction time. So you want to learn about the mental processes involved in reaction time. Well, one thing you could do, I can set up a systematic study where I drop a ruler and the subject catches it. So someone drops it, me or a research assistant drops a ruler, the other one catches it. I think I literally have one right here. Good visual. So here I go. I'm not going to tell you when I'm going to drop it. So what is that? That was 1, 2, 3, 4. 4 inches. So I've got a 4-inch reaction time there. Obviously not the best method because I'm dropping it and I'm catching it. So let's do it again. That time I got 5.5 inches. So I can do that with other people. This was one way that has been used to measure reaction time. But what's a better way? What's a better way to systematically measure that? Here we've got a computer. You've got a little arrow. Hopefully you can see this when YouTube's going to compress this video. So hopefully you can see that there's a little line right here. You should probably see these squares. So maybe when this square turns blue, you press this pad. When this square turns blue, you press this pad. Maybe at the same time, you can be wearing a cap that tells you about brain activity. Maybe you can do this within an MRI machine so that you can actually see brain activation and see what processes and what systems are reacting during a reaction time test like that. So you see we've got publicly verifiable knowledge here. We can solve problems. We can use that reaction time to learn things about how do humans react to a motorcycle being there in the street or a motorcyclist reacting to a car suddenly being where they shouldn't be. It can be relevant to applied problems. So these are ways that we can do systematic empiricism, building on things, using better tools to do a better job of systematically empiricizing things and getting good data. So let's talk about happiness. How do you measure happiness? Well, this is one suggested way. You could literally measure someone's smile. That might or might not work. Maybe some people can smile bigger than others even though they're happier or not as happy. But that's one way you could get a systematic measurement of this many centimeters is their smile. You can also use a scale like this. You might have seen something like this in a pain scale in a doctor's office. So how painful is it? The faces would kind of be going the other way. Like a 10 is really, really bad. You can't really do anything at all. But this is a better way to measure that, a better way to get systematic empiricism. You get your results. You say, hey, people who are suffering from depression, maybe generally they're around this area. So if you see that a client is in this area of this scale, maybe that gives you a little more knowledge to diagnose them with depression. I don't know that it's actually the case. It's just an example right here. You've also got this way to measure happiness. You could take a cheek swab and look at the hormone levels in that person's blood. You could also look at the hormone levels in the brain, but it's a lot more expensive and invasive to do that. So this is generally what we're using right now to look at hormone levels in people's bodies. So science versus pseudoscience. This is a topic that this textbook focuses on quite a few times, so we're going to touch on it in a couple different ways. So astrologists do predict and explain behavior too. So we talked about science or psychology as a science. Looks at the mind, behavior, and mental processes. Astrologists also do some of that, but not in a scientific way. So astrology is a pseudoscience, psychology is not, even though this picture makes astrology look a lot cooler than how I do stats and figure things out. So this is very similar to my to the setup on my desk literally at the moment. I've got my desktop behind my monitors there. I'm looking at this monitor and then I can see my face on the other monitor over here. And it looks like some of the graphs that I would generally be making in analyzing my data. So, what does this mean? Is your image of psychologists and astrologists the same or different? They should be very different in your own mind, especially being in these psychology courses. You should hopefully understand this difference at this point, because psychology is the science using this method, getting this data to explain behavior, mental processes, and I'm generally forgetting one of the three each time, but that's fine. With this being said, I've got a silly example here. The first time I told my grandma about my major, that it was psychology, she thought I was talking about astrology. She thought it was astrology or something similar to it, that it was pseudoscientific. She started talking about different things in regards to astrology. And it wasn't just that she heard the word wrong, she actually didn't understand what psychology actually was. So, kind of a funny story. It's taken a while to get them to, even my parents, to understand really what psychology is and does, which is maybe not a good thing since I'm teaching what is psychology. Maybe I should do a better job. Maybe I should just give them all these videos, let them learn what psychology is that way. So with this, again, this might be a discussion question that is used in the discussion boards for this week. Again, I haven't actually finalized the discussion boards at the time of recording this. So the question is, how should we deal with common sense or folk knowledge? How should we deal with pseudoscience or things that exist of ideas about how people's brains, behavior, and mental processes work? So it's a good question to ask yourself. The different authors that we're going to be reading from their textbooks have slightly different ideas. Some of them say, well, we should do some debunking. In other cases, common sense psychology or folk knowledge might actually give us good insight into what might be happening, how to explain behaviors, but we just have to test it empirically. So others say we should completely avoid it. We don't want psychology tied with the pseudoscience. If we're spending too much time debunking, then we're always going to be tied to that pseudoscience. So both of these things are good. I think the authors have a slightly different perspectives there, and somewhere in the middle is about where I stand. So one of my pet peeves is when people call psychology a soft science. You might have heard someone refer to psychology as a soft science. You might have also. That's okay. It is one of my pet peeves, and we'll talk about it right now. So this is from Wikipedia. So hard and soft science are a perception. So you can see here with the definition is that the distinction is on the perceived methodological rigor, the exactitude, and the objectivity. So as we've been talking about psychology using the scientific method. I can assure you, and this whole class will go over this in more detail, the methodological rigor, the exactitude, and the objectivity of psychology are equal and the same as other fields of science. So it's that it's perceived as not as methodologically rigorous. So hard science includes things like, again, this is from Wikipedia, hard science includes producing testable predictions. We've already talked about a few today. I've talked about a couple that I even had in my science. In my own science, I took previous research in purpose in life and made testable predictions that, hey, these kind of activities that work on those things that we think should increase purpose will work. So I tested those predictions and found out that they were true. So purpose activities, my heroism scale, I've been creating that. With that, I've hypothesized that certain questions will get at people's intention to behave heroically. I make predictions about how things will relate to one another. How does purpose in life relate to gratitude or depression or well-being? How does mindfulness relate to stress? How does it relate to anxiety? How does it relate to well-being again? So I make testable predictions, then test them. So that's what I do. That's what other psychologists do as well. The idea or the perception is that hard scientists do controlled experiments. Psych often uses experiments, but our experiments are not the only valid method. If you take the example of quantum physics, not everything there can be tested with experiments, right? So they are also doing things like correlational studies, like looking at the relationships between elements and variables and things that exist. So controlled experiments aren't the only valid method to get systematic data, but psychology often uses experiments as well. I myself have used experiments in my own work. So the purpose activities that I've already talked about did control groups and treatment groups. The mindfulness activities did control groups and treatment groups. When I'm testing things with people, I'm generally testing them in experimental ways. So with this, yes, I already said this, experiments are not the only method. Experiments are one of the only methods to determine cause. You can use quasi-experiments. You can also use longitudinal experiments, but experiments are kind of the gold standard to learn about A causing B, or actually does A cause D? So with this, the perception is that hard sciences rely on quantifiable data. So quantitative versus qualitative data. Quantitative is essentially numbers. Qualitative is broad, more quality data. You would call an interview qualitative data, but if you're counting how many times that person said in an interview, that's quantitative measure. So a measure of your pulse is quantitative. It's a number. It's you turn it numerical. If you're observing a playground of kids sharing and doing pro-social behavior, you're counting those instances. That's quantitative data. So most of my work, most of psychology, uses both qualitative and quantitative data. So nearly all of my work, almost all of the publications I've done are primarily quantitative, are the numbers, but even my qualitative papers often have quantitative portions to them because I use both. It's better to collect both qualitative and quantitative data when you're talking about humans with the tools we currently have to get a bigger amount of data to better understand what's going on. But yeah, when I'm looking at, hey, did my purpose activities, did they increase people's purpose in life? I have a quantitative measure of purpose that I can give them and see, hey, yes, the treatment group went up in purpose, the control group stayed the same. I'll show those graphs later on in the class too. So, when we're thinking about what a hard science is, or the perception of what a hard science is that hard sciences use mathematical models. So mathematical models are seen as really incredible things to make predictions and demonstrate something complicated in math. Well, correlations are a simple mathematical model. How variable one is relating to variable 2. So we can have how much is purpose in life related to depression, how much is purpose in life related to anxiety, how much is purpose in life related to well-being, how much is purpose in life related to intention to behave heroically. So we can look at that simple model of correlation of this one is related to this one at r equals 0.71. It's a pretty strong positive correlation. So we use in psychology mathematical models. So also we get more complicated than just correlations. We have multiple regressions, we have factor analysis, we have a lot more complicated models than even I've attempted in my own work. Multiple regression or factor analysis I pretty often do though. So these are mathematical models that psychology as a science does really regularly. It's just the perception that people have that psychology does not do these things. So high degree of accuracy and objectivity is seen from hard versus soft science. So with that, that's where you're getting into good measures. So you probably would find people who say, oh, you use hormone levels in swabs as an objective measure of happiness chemicals within a person's bloodstream. Well, that's a high degree of accuracy and objectivity. People might not necessarily see an interview or a survey measure as objective, but they can be as valid as well. Not all of them are. I'll kind of trash on some measures later on in the class that some psychology has used in the past, but we're getting better. We're doing a better job all the time of making more accurate, more objective measures, using better tools like MRIs as well to measure things. So we're doing better at getting at that reliable and valid data. So I hope you get the point from going through this definition. Again, this is a pet peeve, so I kind of focused on it maybe more than I needed to. But these are perceived differences in psychology. So psychology does use testable predictions. It does use mathematical models. It does use experiments. It does use quantifiable data. It does use replicability. It does use measures that are valid and reliable. So these are really just perceived differences. Psychology is a science. It's not a soft science. It's not a hard science. That perception of the distinction there doesn't actually exist. There's just doing science, doing the processes of science, and not. So, should I be mad when someone uses the term soft science? Well, no, I shouldn't be. I shouldn't be mad when someone uses it, but like I said, it's a pet peeve. Sometimes I do get mad. Longer answer, no, it just really shows that people don't understand that psychology is a science. That's one of the reasons we teach this course, so that people in psychology do know and understand and are more science literate. But also it shows that maybe I should do a better job explaining it to my grandparents and my parents at the same time. So a longer answer even. In addition to these points, that no, I shouldn't be mad, it just shows people don't understand that psychology is a science, I can do something to help people's understanding of psychology as a science. I have to consider that people's image in their mind of psychology is Sigmund Freud, Dr. Phil. I have to consider that, and we all do as well, when we think about how to paint and the picture of what we do as psychologists, help people understand more recent research and how that science is done. So we can do a better job at that. So this is a good model of how science is done to work for applied problems. So we have, say, a socially significant problem. So think about a social problem that is of concern for you, women's rights, LGBTQ plus issues, homelessness, any kind of socially significant problem. We can look at what the previous research says. We can do that gathering of what current theories exist. We can talk to political scientists. We can talk to social psychologists. We can talk to sociologists, anthropologists, and we can talk to other psychologists, developmental psychologists, about what does the research say might help with this specific social problem. Then we can get out in the real world. We can look at nonprofits or organizations or schools that are already trying to fight these problems, fix these social problems, and we can collaborate with them. We can say, hey, here's our theory, here's our research methods, what are you doing as well? How can we combine all these things together to try and solve this problem? Then we do something. We try to solve that problem. We get some results. Maybe it worked, maybe it didn't work. Maybe it worked for some groups, but not other groups. So we disseminate that information to multiple audiences. We give evaluation reports to the people doing these kinds of programs already. We try to change policy. We try to change laws so that things are better or different in a way that will improve things based on what we found. We publish to journals. We say, hey, this is what we found when we tried to do this. So hopefully using this system, hopefully you can see it's kind of a cycle here. Hopefully eventually we can use these applied science things, these methods, and working with people to solve these problems. So science and psychology as a science is really applicable to solving social problems, to solving things within our world, to understanding the mind, human behavior, and mental processes. So hopefully you're a little more excited at this point after this lecture about how psychology as a science works. We will continue this on in Stanovich Chapter 12 as well, with coming to more discussions of things like pseudoscience, but a lot of this class does look at science of psychology and really dives into these different things. How do we do this process of science?